This is our lab, and I have removed all the previous network address translation configuration from our firewall. So now let me copy paste this configuration on our Cisco ASA firewall, and here we go. Right, so now we have to generate a TCP traffic in order to witness a static pad taking place, right, because the port numbers are involved. So what I will going to do is that I will going to use a command which is provided by Cisco ASA firewall, and that command is referred to as packet tracer command, right? So let me pick up these commands one by one and explain what is happening. Let me pick up the command number. Let's say first let us do the translation and paste it. Okay, so the command is that packet tracer input then provide the name of the interface. So it means that on a interface inside we are going to feed a packet that our command will going to prepare by itself, right? And we are going to push that packet on the inside interface of a firewall. The packet is TCP packet. Specify the source IP address of the packet. Specify the port number of the packet. So port number of the packet is 21, which is FTP standard port number. So this is source IP, this is the source port number. Now specify the destination IP address of the packet. So packet should be destined to this public host H1. So here basically what we are trying to do is that we are trying to send a TCP packet from web server 1, which is present inside the private network of XYZ Corporation, to a public host H1. So remember, static pad or static NAT are bidirectional. Any of the user can initiate the communication. And the destination port number, as per the configuration, our source port number and destination port number was same. You can see source port number and destination port number was HTTP. So instead of 21 we have to use 80, right? So meaning of this command is that it will going to prepare a TCP packet, and whose source IP address would be 10.0.0.10, source port number would be 80, destination IP address of the packet is 128.0.0.1, and destination port number will be 80. So this command will going to prepare a TCP packet, and it will going to inject that packet onto the inside interface of ASA firewall. So now what will firewall do with this packet will be shown when you press enter. Okay, it's a packet tracer, packet-tracer. So let's see what it will do with this packet. So you should look for this line, static translate, right? So the Cisco ASA firewall is actually translating the source IP address of the packet, which is 10.0.0.10, to the translated IP address, which is 10.0.0.55, whereas source port number of the packet is unchanged, because as per our network address translation configuration, the port number need not undergo any change. You can see that the source port number is specified as same, that is before translation and after translation, so it will not undergo any change, right? So the end result is that only the IP address of the packet is changed. So basically you are witnessing static NAT, because this is the case in which port number is not undergoing any change. So though it is a static pad configuration, but it is giving an effect of a static NAT. So in this line, everywhere you can change the port number to 80. Now let me pick up the first configuration. that is untranslation. So here I am preparing a TCP packet with source IP address 128.0.0.1. Random number, you can pick up any value. So this is the port number, that is source port number of the packet, and it is 3000. And the destination IP address of the packet is 100.0.0.55, and the destination port number is 80. So the packet will going to hit the outside interface of the firewall and it will undergo untranslation, right? So for the untranslation to happen, the destination IP address have to be 100.0.0.55 and the destination port number have to be 80. So you can see when you press enter, you can see that untranslation is happening here, right? The destination IP address of the packet, that is 100.0.0.55, is being converted to 10.0.0.10, which we want, right? So you can see translation is happening successfully. The rest two commands are the commands which I deliberately wrote so that it violate the configuration of our network address translation. So if you pick up the first configuration among these, you will witness that we are injecting the packet on the inside interface of a Cisco ASF firewall. The packet is a TCP packet. The source address of the packet is 10.0.0.10. So until now everything is correct, but the source port number is 180. It is not 80 but 180, right? So as per our network address translation configuration, the NAT rule will be applied only when the source port number is 80. But here source port number is something else. So it means that our network address translation rule will not be applied to this packet, and the Cisco firewall will going to do with this packet what it would have done without NAT. So depending on the destination IP address, the Cisco ASF firewall will going to route this packet without any change, right? NAT is not applied on this packet, so none of the port number or address of the packet will undergo any change, and Cisco ASF firewall would only route this packet as per the routing table, which is a traditional routing behavior, right? So when this packet will go on to the internet, the destination IP address of the packet is 128.0.0.1. So this ISP router will going to route this packet towards public host H1. You can generate a variety of packet types using this packet tracer tool, like ICMP echo packets, ICMP request packets, etc. etc. You can Google or use ChatGPT to generate the equivalent commands of packet tracer tool. But you understood the concept that if network address translation rules are not applied to the packet, then the firewall simply forwards the packet as per the traditional routing behavior, right? So this was the lab for static PAT. The next topic to discuss is dynamic PAT.